If you are learning data analytics or you are a beginner data analyst who wants to start building projects but you don't know where and how to start, this video is for you. In this video, we are going to build a complete end-to-end data project together from the very scratch, starting with where and how I downloaded the data all the way down to the analysis and the dashboard. But take note, this is not just a practice exercise. This is a portfolio project that you can use to demonstrate your data analytics skills. So I don't want you to just sit back and watch me do the analysis. If you can, download the data set. I will show you where I downloaded it and how. And if you want, I can send the data set to you directly. Just let me know in the comment section. So as I demonstrate, open the data set and analyze alongside with me. Pause the video when you need to and just try things for yourself and see if you can get the same result or even better. And if you get stuck anywhere or if there's anything that is not clear, feel free to drop your question in the comment. I'm more than happy to help you out, because the goal here is not just for you to watch me complete the project. The goal is for you to finish this video having built one yourself. So let's get started.
Before I downloaded the dataset, the very first thing I did was verify my question, like what problem do I want to solve with this analysis? What question do I want this dashboard to answer? I had to clarify that first. I have a video on how I planned the entire project on the page. I'll leave the link in the comment section in case you want to check it out. And one thing I've come to understand is dashboard is not just a combination of charts and visuals. As a data analyst, your dashboard or any data project you build is meant to solve a problem. It's meant to answer a question, be it a business problem, be it an environmental problem, just depending on your area of interest. So before you embark on any data project, I would encourage, make sure the very first thing you do is not to download data sets. The very first thing you do is to clarify your problem. If you are working on a business data set, understand the problem you want that analysis to solve. Understand the question that you want to answer with your dashboard and plan it properly. That way it will guide you. That problem that you want the dashboard to solve is going to be the compass that will guide the entire project, because every decision that you make in the course of the analysis, every chart that you use is going to be something that will help you communicate or answer the question that you already listed out that you want to solve. So the very first thing I did was clarify the problem I want this dashboard, this analysis to solve. So having clarified that, the next thing I moved into was data. And for this analysis, I needed historical temperature data, right? So I used NASA Power. I went to the web and put in the website, NASA Power website, as you can see on the screen. Then NASA Power page open up, and then to download the dataset, in case you want to download the temperature dataset yourself or you want to do any other environmental related project, you can get your data from NASA Power. In NASA Power, you will see data for temperature, rainfall, relative humidity, and other environmental related datasets. So when you get to NASA Power homepage, left side of the screen, I went to single points. Under user community, I picked hydroclimatology, and under temporal level, I picked monthly and annual, because that's the temperature data that I want. I want monthly and the annual temperature, not daily. Under location, here in location, you're going to input your coordinates, the latitude and the longitude for the location that you want to get. I have 6 locations that I'm working on. So I had earlier gotten the coordinates, the latitude and the longitude for each of these locations. The first location I'm working on is Abuja, so I put in the latitude and longitude for Abuja. Automatically, NASA Power directed me to Abuja on the map. And the next thing I did was time extent. I'm working on 1990 to 2025, so I imputed that. And then parameter, I want temperature at 2 meters. That is temperature at 2 meters above the ground. Under data download, I need the data set to be in a CSV file. So I pick CSV, I click on submit, and then the data set is downloaded. And I did that process for all the 6 locations, one after the other. So at the end, I had 6 separate tables, each representing the 6 cities that I'm working on.
So here's the first location we'll be working on that I've opened after downloading the data sets. The first thing I'll be doing is I've explored the data. I've seen that everything is complete from 1990 to 2025. I've seen that it is complete, and I've also seen my temperature data that there are no missing values. Right. The first thing I'll be doing to my data set is to clean it. We'll be cleaning the data together, because you see these first 9 rows from here to here. These first 9 rows, they are not useful for my analysis. They are just information about the data set, talking about the location, that's the latitude and the longitude, the elevation. I don't need them, so I'll need to clean it off. Also, I'll be removing some columns, like this parameter column A. I will need to remove it out, and even this column O, this annual temperature, I don't need it. I need annual temperature, no doubt, for my analysis, but I will calculate it myself eventually when I'm ready for analysis. I don't need it in this format. And then I'll also be transforming the data set. I'm just giving you a breakdown of the cleaning and transformation we'll be doing with the data set. I'll also be transforming the data set. You see that the months are spread out, like I have January, February, March to December. They are not supposed to be like this. They are not supposed to be spread out. I want months in one single column, where each rows will not be January, February, March, right? So I need to pivot the month, so that I have my month as one single column. I'll be doing the cleaning and transformation in Power Query Editor. So to go to Power Query Editor, click anywhere inside your data set, come to your ribbon, click on data. from data come to from table/range. We click on it. This dialog box open up. It's supposed to make your data set a table before you can continue. So I just check this, my table has header, check it, and then okay it. Once you do that, your data set will load in Power Query editor. So yeah, this is the data set. So what the first thing we are going to be doing is cleaning. I need to remove the first 8 rows. But first, let's see our data. You can see that our data contains 15 columns and 45 rows before any cleaning and transformation. To check that information, just come to the bottom left of your screen. See where my cursor is. You will see that summary information about your data set. That's how many columns and how many rows your data set contains. And so the first thing I'll be doing is to remove the first 8 rows that we don't want for our analysis. So to do that, I click anywhere, go to the home tab in your ribbon, Power Query ribbon. See the home tab, see where my cursor is. I'm already at the home tab. Then I come to remove rows. See, I click on remove rows. So under remove rows, that you click on the drop down beside by the remove rows. Then you see different options: remove top rows, remove bottom rows, remove alternate rows, depending on remove duplicate rows, remove blank rows, remove errors. I'm not removing duplicates because my data does not have duplicates. I'm not removing blank rows because my data has no blank rows. So what I'm doing is I'm removing top rows. So I click on remove top rows, and then this open up, specify how many rows to remove from the top. So I want to remove the first 8 rows. So I type in 8, I click on OK, and then I have my data clean. The 8 rows have been removed. The next thing I'll be doing is to remove the columns that I don't want. So I will click on this column, press down the Control key, and then I move to the last part of the column, and then I click on this column 14. I'll come to under the same home tab in the ribbon. You see another part where they say remove columns, and then I click on remove columns, and voila, the 2 columns I highlighted has been removed. So what I have now is my year column and the months column from January to December. From January to December column, that's what I have. But I want you to pay close attention because this was what I tried to explain, the mistake I made. So that when you're doing your own, you will not make the same mistake that I made and spend hours trying to figure out what you did, what you are doing wrong. If you see here, if you check the first column, the first row of our data set, are you seeing this first row? No, this row here where we have column name, where I have column 1, column 2, column 3. See the box beside it by the left side. So you see it has A, B, C, and 1, 2, 3. For all of my columns, it has A, B, C, and 1, 2, 3. Each columns that I have here in my data set contain numbers, figures. So I'm not supposed to, they are not text. The columns does not contain text. But Excel is not recognizing it as figures, as columns that contain figures. Here, Excel is recognizing my columns as having both text and numbers. That's why I'm having this ABC and 1, 2, 3. I made this mistake earlier because I did not pay attention to it. I just went ahead to one pivot and I have error. See the error I was getting. So that error happened because Power Query did not recognize my column headers, as you can see. Instead of using the first row, this row 1, as the column names, so Power Query treated my column names as normal data. So the first row became part of the table instead of being the headers. That's what happened. It means that each column now contain a mix of text and numbers, as you can see from this box. For example, this temperature column for January, the temperature column should only contain numbers because I have only decimal numbers in the column as my temperature value. But because the word January was sitting inside the column, Power Query saw both text and numbers. Text and numbers together and could not assign the correct data type. So that is why we are having this box. We're having both ABC and 1, 2, 3. indicating that our column contain both text and number, which should not be. So to fix that, go to your ribbon, Power Query ribbon, go to transform. Transform is beside home. Go to transform. You see in transform, you see here, see where my cursor is. You see use first row as headers. So we click on it. There are two options under it, which is use first row as headers and use headers as first row. But in our own case, what we want is to use first row, which is this. We want to use this our first row as headers. So I will click on use first row as headers, and voila, you see the first row has now become our headers. So if you now look at the box beside the column name, the column header, you see that they are all having 1, 2, 3, 1.2, 1.2. The text figure is no longer there. If you open it, you see. So this is where you change your data type. And I will emphasize this again and again because of the frustration I felt when I was working on this, and I didn't pay attention to it. I didn't realize. So I don't want you to feel the same. This nearly made me abandon the entire project because I was discouraged. Also, you don't feel the same way. So if you have a data set, you have your data set in Power Query, and maybe Excel is recognizing it as text, and meanwhile the data type is number, right? What you need to do is go to the column, the box beside the column name, just click on it. See, you have different options of the data type, so you can easily change. You can easily change the data type that is there. So my temperature value contains decimal number. You see, that's why we're having 1.2, 1.2 in by the column name, because they are decimal number. And if you look at the year column is simply number. There is no decimal. And that's why you see 1, 2, 3. So they are whole number. And because we have cleaned it properly, Power Query could easily assign the right data set, the right data type to the column. And that's what we have here. So if you're working with a data set and you want to, maybe Power Query did not assign the right data type to the column and you want to change it, simply click on this box beside the column name and you change it. So this, you just click on it and change your data type. Make sure you pay attention to it. Make sure your columns contain the right data type before you continue. Make sure, I'm repeating it. It may seem like I am repeating it again and again. I am doing so because I know what can happen to your analysis if you don't pay attention to this. So make sure your data set, each column contains the right data type. If your column contains text, make sure what you are seeing here is ABC. If it contains number, the whole number, make sure it's 1, 2, 3. If it contains currency, make sure you are having currency symbol there so that you will not face the error that I face. So let's move on. Our data set is clean now. It's no mixed data types and all. So the next thing we're going to be doing is to unpivot. Like I explained earlier, I'm having January, February, March, each month spread out, but I want a single column for all the month. I want all the months to be in a single column while each month becomes a row. So to do that, I want the year column to remain the same. The year is already a single column of its own, like this, and that's how I want the month column to be. So to do that, I click on the month, I highlight my year column, right? Then I come to transform, then click on transform. Under transform, you come here, come to unpivot columns. See unpivot columns. Click on the drop down beside it. We have 3 options, which is unpivot columns, unpivot order columns, unpivot only selected columns. I want other columns unpivot. These are the other columns that I want to unpivot from January to December. So I'll click on unpivot other columns, and voila, you see it has been done. So I have my year column, I have my January, that's my month column, and then I have my value, that's the temperature values. This is my Port Harcourt location. You can see that because we have cleaned our data properly, Excel could easily has assigned text data type to attributes, that's to month, and then the year still has 1, 2, 3, that's whole number, and my value, which is the temperature value, still has decimal number. We are good to go. So what I'm going to do is to change the name, edit the name of this. It is not attribute, it is month. I'll change it to month, and this value I'll change it to temperature. You see the good thing with Power Query. See all these steps that we have taken, everything that applied steps, everything that we've done since we moved our data to Power Query, they are all listed here. We've changed data type, we removed top rows, we removed columns, we promoted headers, we changed data type again, and then we unpivoted other columns, and then we renamed columns. So the good thing with Power Query Editor is any apply steps that you don't want, maybe you made a mistake and you want to cancel that step, you can easily click on, see this X sign beside the apply steps, you just click on it. You see, as I click on it, the column name that I changed, the columns that I renamed, it has gone back to the way it was. So that's the simple way you can cancel and apply steps. So the next thing we are going to be doing is we are going to be adding extra columns here, and that's because if I leave the table like this, by the time I merge it with the other 5 tables, I will not know which location, which is which, right? So I need to put a different columns that will carry the name of each location. Okay, I come to the ribbon, click on add column, and then I click on columns from example. So I click on that. I will change the column name to location, and then this one is Port Harcourt, so I put Port Harcourt. In the second row as well, I type Port Harcourt, and then I click enter. You see what happened? Because I use column from example, after typing the first 2 rows, Excel automatically fill up the remaining rows. If I didn't use this, I will have to be typing one by one for over 432. For 432 rows, I will have to be typing Port Harcourt. But Power Query Editor could easily identify, okay, this is what I'm trying to do, and filled up the remaining one for me. So I just click enter. I just click OK, you see? And I have all my location here. I will be adding another column to show the zone. Column from example again. I click on it. This one is going to be, the column name is going to be zone. That's geopolitical zone. This zone here is South. And then I click enter. Power Query has filled the remaining columns for me, so I click OK. And I have location. So the next thing I will be doing is to rearrange my columns in such a way that I have zone first as my column 1, location as column 2, year as column 3, and like that. So I'll be dragging. I've highlighted the zone, I move to the first one, so yeah, then location, the second one, I move it. So yes, I've reordered my column. So I have zone, location, year, month, temperature. So this thing I have done, all the steps, all the apply steps that I did for this first location, Port Harcourt, I'll be doing so for the remaining 5 locations. Mistake number 2 that I made. After I finished cleaning the location, the mistake that I made was I came to home, and normally you're supposed to close and load. If you're only working with one data set, you close and load, and you will load your data back into Excel. But I am not done. I want to merge all tables together to form one mega table. So the mistake I did was I just close and load, and then I went open the second location, clean it, close and load, and I did that all for the 6th location. When it was now time to merge the table together, I could not, because there were 6 separate tables, and I had not stored the query in Power Query, so there was nothing to join. So to correct that, when you are done, if you have different tables that you want to merge together to do your analysis, instead of close and load, click the drop down under close and load, and then you will see close and load to. Instead of close and load, click on close and load to. This dialog box will open, and you see you click on only create connection. Check only create connection, and I okay it. So I have it here. I have my query here. So the next thing I will do, I need to bring in, don't close your Excel to go and open the next location, the next table on its own. What you need to do from here now, we'll bring in the next table and we'll clean it. So go to data on your ribbon, Excel ribbon, go to data, come to get data, click on get data, and from file, I have my table from file. From file, then you see from Excel workbook, from text, my raw data is a CSV file. So you click on CSV, go to where you store your data, the folder where your data is. So raw data, I click on this and import. So this is the data. This is the next location. You see, we have load, we have transform. Don't click on load, go to transform because we need to transform it. So the data will open in Power Query. So we do all these things that we did for the cleaning steps that we did for the first table, we do it again. When you are done, you go to home, then you go to click on close and load, or close and load to, and then check on only create connection, and okay. So we have 2 locations here. So you do that for, I'll do that for all the other tables so that I have 6 connections here. And then after that, we'll now join the tables together. So let's assume I have all my table here, 6, and I want to join them together. So these are all the tables, all the queries that I have stored, and I want to join it together. I come to transform, then I go to close and load, this close and load. So this is it. These are, let's assume this is all our queries that we have here. This is just a sample. This is 4. I have 6 locations, so I already did it. I just want to show you. So this is 4. I want to merge this 4 table. I want to merge all the tables together. So I go to get data like we did, but I'll come down to combine queries. Under combine queries, I come to combine queries. Under combine queries, there are 2 options, which is merge and append. Now, what's the difference between the 2, and which one do we need? If you already know, you can just drop it for me in the comment section before we go into explaining that. A lot of beginners confuse merge and append, but the difference is actually very simple, right? Think of 2 class attendance sheets. You have 2 class attendance sheets, right? And so append is like placing one list on top of another, right? To make one longer list. So it's like stacking your tables on top of each other. Append. When you append, you stack your tables on top of each other, which means the rows become longer while you maintain the same column numbers. The rows will increase, but your columns will remain the same. So you are adding more rows in append, right? But merge, on the other hand, is like joining 2 attendance sheets side by side. If you are merging your table, it means that you are joining your tables together side by side. If you remember join function in the join function in SQL, this is doing the same thing. So you are joining your tables together side by side. In merge, just a simple way to remember, in merge, your columns are increasing while your rows remain the same. Whereas in append, you are having one long table. So in our case, we want to append. We want to place the tables on top of each other, right? We want one long table. So I click on append. When you click on append, this box will open up. You see, we're having concatenate rows from 2 tables into a single table. So in append, it is the rows you are joining together. You are joining by rows, while in merge, you are joining by columns. I have more than 2 tables, so I click on 3 or more tables, and here this open up. These are all the tables. If you store your query, if you did a query properly, if you follow the steps that we've just done, you will have all your available tables here. I have only 4 here, whereas I have 6 locations. Remember, I said I have done this before. I'm just using this to illustrate. So you have all your 6 tables. If you are working with 6 tables like me, you have all your 6 tables here. So because we want to we want to append all the 6 tables, I am going to move it from available tables to tables to append. So I click on, I want to highlight, instead of moving it, there are 2 ways, right? There are 2 ways you can do it. You can click on it one by one, click on table 1, you click add, you do it one by one like that, add, or let me cancel, or you just click all at once, which I think this is better to save time. So click on table 1, press down your control key, and then click on the other tables with your control keys pressed down, and then to have highlighted, you see I've highlighted all the tables, and then you click on add, and all the tables comes here at once instead of doing it one by one. So I click on, after doing that, I click on OK. So after moving the table, after appending the table, this is what we have. We have all the tables together. There was an error here. Error is that one of the table was not cleaned. We didn't rename the column. We didn't rename the column name. Anyway, so this is something you need to pay attention to. Make sure if you want to append, you want to join your tables, especially using append, make sure your column names are the same. Make sure your column names are the same. If not, you will have this error. This is just a sample that I did to show you what will happen if one of your table has a different column names. It's going to join it side by side instead of appending. Remember, we're supposed to maintain the same number of columns, which would have been just 5 columns, which is zone, location, year, month, and temperature. That is the initial 5 columns that we have. But if you are merging a table, maybe you are merging 3 or more tables together, or even 2 tables together, and the column names are not the same, the column headers are not the same, this is what Excel is going to do. It's going to join it side by side instead of stacking it. It's going to do merging instead of doing appending. What will happen? So you see, it added extra 3 columns for us because these 3 columns has a different name from this. So he only joined the other location that has the same column names. So pay attention. So that is how you do your appending, how you append your tables, how you join your tables together, how you clean in Power Query and all. So the next thing we are going to be doing, is to do our analysis using pivot table. So we'll be moving on to pivot table. So I go to the home tab, go to close and load. I close and load my data. So this is our data set after the cleaning and transformation that we did in Power Query Editor. This is the data set. Having cleaned our data and merged all the tables together into one mega table, the next thing we'll be doing is exploratory data analysis, also known as EDA. This is our final data table, our final table, the mega table containing all the 6 tables. So we have the zone, we have the city, we have the year, month, and temperature. Pivot table is an inbuilt Excel platform that helps you summarize your table. If you're having large amount of data set, instead of doing aggregations manually or summarizing the table manually, pivot table helps you summarize your data within a split second without even writing a single formula. To use pivot table, click anywhere inside your data, right? Then go to the ribbon and click insert. Then you will see pivot table here. So click on pivot table and this panel opens up. If you see under table/range, you see that append 1 is written here, is picked. Append 1 is my worksheet where the data set I'm working with is. So when you are doing your own, ensure that this table/range has your data sets. Ensure that it correctly pick the range of the data set you are working with. Because I'm working with the whole worksheet. I'm working with the whole data in the worksheet. That's why you are seeing the name of the worksheet here. Assuming you are working with just a section of your data set, you are not working with the whole data set. Maybe you just want to you just want to use like 2 or 3 columns for your pivot table. Make sure that at this point you correctly enter the range of your data set here. And then here, choose where you want the pivot table to be placed. You can either place your pivot table in the existing worksheet, that is where you have your data set, you have your pivot table by the side, or your pivot table opens in a new worksheet. So I want the pivot table to be in a new worksheet. So I check this, that's new worksheet, and then I click OK. This is our pivot table environment. It has opened in a new worksheet called sheet 3. I will rename it to pivot table. This is the pivot table interface. You see, this is where the pivot table is going to be when we build it. And this is pivot table field. At this point, you see all our columns from our table, zone, city, year, month, temperature. This is it. So in this section of the pivot table field, all the columns that you are working with, all the columns that is on your data set, the one that you highlighted in your table range will appear here because that's what you'll be working with to create your pivot table. And then this is where you do the summary. These sections are what is going to summarize your data. This section are what you use to tell pivot table that okay, this is the columns I want, this is the kind of aggregation I want. I know. for this analysis, what I want to do is to get yearly average. That means you know that my data set, where is this? This is the data set. You know that the data set we have months, and months has January, February, March to December. So 1990 alone has 12 rows. That's from January, to December. So I want it summarized in such a way that 1990 will have only one row. So it will give me all of this January to December. I want the average. I want the average of all of this temperature value from January to December. What is their average? So that I have 1990 as a single row, and then the temperature value, the average temperature for 1990. That's the aggregation we are doing. So I want to get the average temperature for each year. Let's go back to our pivot table. So I just had to explain that so that you understand what we are doing. So what we are doing now is to get yearly average. So the first thing to do that, I will move my year column into row. As you are doing that, look at the changes that is occurring in our pivot table area in the section where we'll have our so the row labels has already been identified as the year, because I want to summarize. I want the year to be the rows. Then I want to aggregate by city. I want to know the average temperature per year for each city. City is going to be my column. You see, when you put it there, you will see, so that you, from here, you'll be able to see if what is giving you is what you have in mind, is what you are trying to. So just understand what you want to solve, what you are doing, so that by the time you are putting what goes where under row, columns, and value here, you will know. By the time it's giving you the output here, you will know if that is actually what you have in mind, what you are trying to do or not. The value I'm summarizing is the temperature, right? So I'll drag temperature into the value areas. So now you see we have the year is now our row, the city is our column, and we have temperature as the value. But if you go back to pivot table field, you will see that under value we have sum of temperature. But it's not sum we want to do. We are looking for average. What this sum means is that pivot table summed all the temperature for each month. That means this 1990 for Abuja, this is the sum of temperature from January to December. This is the sum of temperature in Enugu from January to December in 1990. But that's not what I want. That's not what we want. We are not looking for sum of temperature. We are looking for the average temperature. To change the aggregation to what you want, I think Excel automatically usually picks sum, right? So if the aggregation you are doing is not sum, click on the drop down beside the sum of temperature. This drop down here, this place. When you click on this drop down here, click on value field setting here, this last option. Click on it, and then you have all the option here. You see custom name is sum of temperature. That's not what we want. So you can change. You see you have sum, you have count, you have average, max, mean, products. That's multiplication. You have standard deviation. So any kind of aggregation you want to do is here. So what we want is average. So I click on average and okay, and yes, if you see here now, it has changed to average of temperature. So this is the average. So this means that the average temperature in Abuja is 24.72, and average temperature in Enugu in 1990 is 25.26. So yeah, we have a summary table for the location, and this grand total, you see that Excel pivot table automatically added a grand total column for us. This grand total column simply means this is the overall average. So yes, in Abuja this is the average temperature in 1990. This is the average temperature in Enugu. For each of the location, this is the average temperature, right? What this grand total means is the overall average. Merging all these locations together from Abuja to Port Harcourt, all the 6 locations, this is the overall average. So since I'm doing like analysis for the whole Nigeria, and I use these 6 cities to represent Nigeria, so that they will give me an estimate of temperature trend in Nigeria. I'm using these 6 cities. So that means that in the whole of Nigeria, based on this sample size, the average temperature in Nigeria in the year 1990 is 26.06. So we are going to be formatting our table. To clean it, I'll click on the columns that I want to clean. So to do that, you just highlight your data set, pick on all of it, all the numerical value that I want. Then I come to here, This is increase decimal, this is decrease decimal. This thing is found in the home tab of your ribbon. So I click on decrease. So I already have 2 decimal places. I'm okay with this. So yeah, this is our yearly average temperature. The next thing I'll be doing is to use pivot charts, visualize this for each location. So what I'm going to do is, I don't want this grand total. Okay, so let me rename it from grand total into overall average. I'll be using a line chart to visualize temperature trend for each of these locations. To do that, I'll click on this. I don't want to include overall average. I'll click on just the column and the row that I want for my line charts. If you check down, I still have another overall average per location. So I stop at exactly 2025. I did not include the overall average down here. So I go to, after highlighting the columns that I want for the analysis, I go to insert, and then I come to charts. I click on line charts, and here is it. So let's move it here so that we can see it clearly. So this is our line chart, but you see that it's looking very confusing, right? It doesn't really make sense. It's not readable. All the lines are squeezed together in one place. They are in between 25 to 30, right? So all of this down part from 0 to 20, they are all empty. So we are going to be formatting this chart to space out our chart to make it readable, right? So to do that, I want to do something here. So I click on the vertical side of the charts, the numbering by the vertical side, and I right click on it. I come to format as is. Click on format as is. This format as is panel opens up, so you can see that the minimum under the as is options, the minimum I have is 0. That's what's automatically generated, and the maximum is 35. Whereas in my data set, the minimum value in my data set is about 24. I don't even think it's up to 24. Maybe the minimum is about 25 point something. Okay, I have 24 point something as my minimum. So I want my minimum value to be 24, because I don't have any value that is less than 24 in my data set. So I want my minimum value to be 24, and then my maximum value in the data set, I don't have any value higher than 30. I've already checked. I have 29 point something as the highest temperature in the whole of the data set. So I want my maximum to be 30. You can see it all spaced out. I will also be doing further formatting, like color formatting, headings, and all of that formatting when it is time to build the dashboard. But for now, let's just keep it at this. When we are building our dashboard, when we've chosen our dashboard color and all, I will use all that now. I will use that now to properly format the chart. So for now, you can see that it's a bit clearer, it's spaced out, and the chart is clearer, it's readable now. You can see the city. This city here is Abuja. This one up here is Abuja. You can see it here. We'll be doing all that chart formatting in the next video when we are building our dashboard. The next analysis I'll be doing is to calculate the minimum temperature and the maximum temperature, so that I'll get the metric for which year is the hottest year and which year is the coldest year. Increase to 39 instead of the 37 that we used, but we have seen it now, so let's quickly change. Let's see the average temperature pivot table. I copied the average temperature pivot table and pasted it here. You can use the same worksheet for all of this. You don't have to go to a new worksheet. You don't have to go to a new worksheet, but I did this so that it will be clear. We're going to be using sorting to know the coldest year and the hottest year. So you come here under the drop down by row label, click on it, and you have sorting option. You have sort smallest to largest, sort largest to smallest. If we use any of this, so it's not going to give us what we want. So let's go to more sort option. So click on more sort option, and then this dialog box open up. You have manual, you have ascending, that's A to Z, and you have descending, that's Z to A, to know which year has the highest temperature value. So we want the highest, that's descending. Let it come from highest to lowest. That's what this descending means. Ascending is let it climb up. That's let it go from lowest to highest. That's what ascending means. So I click on descending, and you see here is year. It automatically picks year for us, but we don't want to sort by year. If we sort by year, what we are going to be having is the highest year between 1990 to 2025. Which one is the highest figure? Which one is the highest year in terms of numerical value? But we are not sorting by year. We want to sort by temperature value. Temperature is our focus. The highest temperature is what we are looking for. So you go to this drop down by year, and you will see average temperature. So we want to sort by average temperature. So we click average temperature. So you can see summary, sort year by average of temperature in descending order. So this summary already gives us clue what we are looking for. So we click OK, and voila, we have it here. So we can see that 2025 happens to be the hottest year, with temperature value, overall average temperature of 27.32 degrees Celsius. Remember, all these are temperature values, so they are in degrees Celsius. So we're having 27.35 degrees Celsius. That's the hottest year Nigeria has recorded from 1990 to 2025, using this 5 location as our sample size. This is like a proxy indicator. This is not like the overall, because I only use 5 cities to give me a proxy indicator of what temperature trend looks like in Nigeria. So judging from these 5 cities that were carefully selected to represent the different zones in Nigeria, their findings now show that year 2025 was the hottest year in Nigeria. We average temperature of 27.35 degrees Celsius. We can also see here from each location, between 2023, 2024, and 2025, they are the top 3 hottest year in Nigeria between 1990 to 2025. I did not include the coldest year in my charts dashboard. I didn't include the coldest year, but if you want to include it in yours, you are going to do the same sorting method to get the coldest year. And let me just quickly show you. You copy the temperature data again, paste. So to get our coldest year, I simply copy our pivot table, the average temperature pivot table again, and pasted it here again. So we want to get, so in case you want to include the coldest year in your own dashboard, you simply do what we did while we were sourcing for the hottest year. So you go to here, go to the drop down here, click on more sorting. You come to, but this time instead of descending, you go to ascending. I explained ascending and descending earlier. You go to ascending, and then you go to this drop down, click here, and then go to click average of temperature. We want to sort by average of temperature. Okay, so yeah, you see that means the coldest year in Nigeria since 1990 to 2025 is 1994 with an average temperature of 25.39 degrees Celsius. So the coldest year Nigeria has recorded between 1990 to 2025 is an average temperature of 25.39 degrees Celsius, and the hottest year Nigeria has recorded between 1990 to 2025 is 27.35 degrees Celsius. So you see, this is the hottest year between 1990 to 2025, 27.35 degrees Celsius, and this is the coldest year between 1990 to 2025, 25.39 degrees Celsius. One thing I will encourage, don't just, if you want to recreate this dashboard, right, you want to do this project and you want it to be your own portfolio project too, don't just copy me word for word, right? Try to like tweak your own, add some addition, make your own even richer than my own. And how can you do that? I use just 6 cities as my own to give me a proxy indicator of temperature trend in Nigeria, right? But if I were to do this project again, if I were to improve on it, I will not use 6, right? I will use more than 6 cities. If you can even use 1 city to represent each state. So that means you have like 36 cities plus Abuja, which is the FCT, the Federal Capital Territory. that with 37 cities. So you can use like 37 cities. It will give you a better idea, a better picture of temperature trend in Nigeria. Like the figure will be a bit closer home, be much more accurate than my own, because me, I'm only using 6 cities and temperature varied, right? Temperature varied by zones and all. Well, this was just me doing something like a beginner friendly project, but I'll be working on this again. I'll be working on this particular project again much later, whereby I will add other parameters, not just temperature. I'm just giving you a clue. So you can also do that to make your project to stand out more, to make your project stand out more. You can add other parameters if you're interested in climate data analytics. If not, you can get any data set, but let the data set be meaningful. Let it solve a real problem, right? You can get any other data sets that you're interested in, and you can just follow these steps to analyze it and get insight that solves your problem from your data set. So now we have the hottest here and the coldest here. So this is going to be our KPI. So we are done with that. Let's go to the next analysis. So the next analysis I want to do is to do a comparative analysis. I want to do a comparative analysis of the 6 zones between 1990 to 2025. Which of the city has the hottest temperature? I want to compare their temperature to know which city was the hottest, which city was the warmest, right? So to do that, we'll go back to our original data set. That's the mega table where we join all the 6 tables together. So we are going to be inserting a new pivot table. So I will be doing that on a new worksheet. Go to new worksheet, click on new worksheet, click OK. We have our pivot table in a new worksheet. So you come to your pivot table field here by the right hand side of the screen. I want to do a summary by city. I want to compare city. So I bring city to the row. So I bring temperature to value. That's all we need for this. So we have our city and we have temperature, but see, it's sum of temperature. It's not sum we are looking for. We are looking for average temperature. So we are going to be changing that. Click the drop down and then come to value field setting. Value field setting here. Click on it and then we are able to change from sum to average. Okay. So yeah, we have our average temperature per city. So let me just clean it because the decimal places is too much. So let's reduce it to 2 decimal places. Yeah, we can see in terms of average temperature, Abuja and Enugu has a tie. So Abuja and Enugu has the same average temperature of 25.38 degrees Celsius. So let's sort it so that we know which one is the highest and which one is the lowest. We come to more option. We come to descending. We want to sort by average temperature and then OK. So yeah, we have sorted our table. We can see that Maiduguri has the highest average temperature of 28.33 degrees Celsius, followed by Lagos. The city with the lowest average temperature is Abuja and Enugu. So I am going to be including a pivot chart here to represent this. I don't need this grand total, so we can just delete it. Okay, they say we can't make changes, so let's just leave it, but I don't need it. This is overall average temperature. So okay, I think we might even need it because it means that in Nigeria this is overall. So this is the overall average temperature in Nigeria, 26.25, using this 6 city sample size. Okay, so let's include our pivot charts to represent this. We go to click inside your data set, go to insert, go to chart. I want to use bar charts. Let's use this 2D. Yep. Alright, so we have Abuja, we have Lagos. Because we have sorted our table already, you see that the chart is arranged also because our table is sorted. So yeah, that's it. You can now change your when we are doing our dashboard, we are going to format the chart. So yeah, we can say that this is the temperature, this is the average temperature, this is the average temperature per city. But how fast are this temperature increasing? What is the rate of increase, the rate of change, right? Between 1990 to 2025, what is the rate of temperature growth, temperature increase in Nigeria? That is what warming rates help us to understand. So to estimate how fast each city is warming over time, I'll be using Excel slope function. So I'll be using slope functions to calculate, to estimate how fast each of the city is warming over the study period. So to do that, the first thing we are going to do is to get this our table again. This table is a lifesaver. We are going to use this table again. Okay, this is the sheets. Please name all your sheets. So we are going to let's put it here. So yes, that is the table. Our average temperature table. So the first thing we will do after we already have our average temperature. Let me explain briefly the Excel slope function. The slope function helps to calculate the average rate of change between two variables. That's the purpose of the slope function. In this case, the temperature is my dependent variable, which is y. Time is my independent variable, which is the x. So the slope function helps you to just know, to determine or estimate the rate of change between your dependent variable and independent variable. Back to this, let me show you the slope function. So let's say equals to slope.
I made a table, separate table that included what I want to show on the map.
So it returns the slope of the linear regression, the linear regression line through the given data points. That's what the slope function does. Let's see what it takes.
Give it a little time, the map will load, but you will need your data on for this. You click on accept again on that. Click on accept.
So we can see the known y's and the known
your map
x.
will load
And like
based
I
on the
explained, that's
information
what
on the table.
This function takes in the parameter you need to put into the slope function, the known y's and the known x. In this case, the y is our dependent variable, and our dependent variable is the temperature. And our independent variable is time. That's the one that's constant. The independent variable is time. So the time series here that we have is this, our 1990 to 2025. But I am not going to be using this like this. I want to put a number. At first glance, you might think I could simply use the actual years as my known x. That's the time variable. 1990 to 2025. You might think I could simply use the actual years as my x values. Technically, that can work, right? However, I'll be creating a separate column called the year number, where 1990 becomes 0 and 1991 becomes 1, 1992 becomes 2, and all the way down. So let me just show you how I did. So to calculate rate of change for each of the zone, the rate of temperature change, the first thing I'll be doing is to create a number here. By the way, if you want to copy this your average temperature table, make sure you do not reference, you just copy it as value without referencing the pivot table. Let's not copy as a pivot table. If not, you will not be able to edit it, because with this analysis I'll be including extra column. And if you copy if you copy it as pivot table, you will not be able to add a column to it. Let me show you what I mean. Let's say we copy this right now. This is our pivot table, and let's come here. Let me paste. So if you want to paste it as value, this option. If you paste it as value, you are not referencing the pivot table. You're only pasting the values alone. That way you can do all your editing. You can add columns and you can remove columns. You can add columns and whatever you want to do. But if you paste it as a pivot table, you cannot add extra column. So I hope you are seeing the paste option. So what you're going to use is value. Alright, so I just thought to show you that, like, this is what I did here. So that's why you're not seeing This is not, this is just value that I pasted. For my slope function, I need the x value and the y value, right? And like I explained earlier, the x is the independent variable, which is the time, which I'm going to be using this year. But I don't want to use, at first glance, you might think I could simply use this actual year, the actual years, that's 1990 to 2025, as my x values. Technically, that may work, but I created a separate column, but I'll be creating a separate column called year number. And there, 1990 will become 0, 1991 will be 1. I want 1, 0, 1, 2, 3. I want to label my year value like that, so that, you know, the time starts from 0, so that the time will start from 0, and it will make the analysis much easier to interpret. The slope also will become easier to understand if I use that anyway. So to include a separate column, I will click on the B, that's Abuja column, the second column, right click on it and click on insert. So I will rename it to year number. To convert this to number series starting from 0, this is the formula I'll be using. I will use equals to A2 to, I'm supposed to use A2 to minus A2. So I'm going to be subtracting the previous year value from the next one. So it's going to be 1990 minus 1990, then 1990 minus 1991, 1991 minus 1992, like that. But I'll be using an absolute value to lock this 1990 so that it does not change for the rest of the row. Let me show you what I mean. So I'll be using the $sign and a $sign and 2. This is an absolute reference. It's called absolute reference, which means as this progresses, if I move to column 3, column 4, column 5, this absolute A2 remains the same. It does not change. Anyway, I'm going to be explaining, or we're going to be going into detailed explanation of formulas and functions in Excel eventually soon. So just stay with me. If you've watched the video to this point and you have not subscribed, please click on the subscribe button so that we can learn all of this together and understand it better. So anyway, I'll be using absolute reference for this. So this is what this means. I'll be explaining that in detail when we go into understanding Excel functions and formula. I click on enter. So I have 0. That is what I just did is 1990 minus 1990. That's why I have the 0. So I just double tap and automatically, let me show you what I did. I want to autofill the remaining rows, right? Instead of, you have two options. Instead of repeating the formula for all of the column, that's option 1, which is long route. Option 2 is to click here and drag till you get to the down. That's an option 2. You will drag it down, which is also another long, though shorter than the first. Why option 3, the smartest way? Once you just come to this edge, once your cursor turn to this plus, double click, and then automatically Excel autofills the remaining one for you. So I have my number value from 0 to 35. See. The next thing I'll be doing to create the slope function for the rates of change, I'll be creating a short table here where I will use city and slope, that is rate of change. Let me just use rate of change. So I will put Abuja, just input your city. So for my rate of change, I'm using slope function, so equals to slope. You can see this is the variable that we need for the slope function, the known y's and the known x. Remember I said x is the independent variable, which is the time series, which is the time in this case. Why the known y's is my dependent variable, which is temperature. We'll also be, this is statistics, which we will cover much later. Let's just, so you don't have to go into, if you don't have understanding of statistics, you don't have to work yourself up about it. It's something that can be learned. It's something that you will learn and you will understand. Just know something that in statistics, there's what they call dependent and independent variable in statistics. We'll cover that later. So my y, known y is, I'll be used, let's do Abuja first. So I have Abuja, that's C2 to C, the last number there is what? Okay, C37. So C2 to C37, that's our known y. Then known x is B2 to B37. Let's see, we got that right. All right, so yes, we did. We close our parentheses and we click enter. So this is the rate of change for Abuja. We're going to do that for all the other city. So equals to slope. The next location is Enugu. So we have D2, the known y, D2 to D37, comma, and we maintain our year number, which is B2 to B37, close parentheses and enter. E2, what's the typo? E2, E37, B2, do you want to accept this correction? What's the typo then? Equals to slope, E2, E37, B2. Okay, it's good for you to read all of this so that you can easily debug your code, your formula. You know what your error is saying. See where the error is. I use double parentheses at the end instead of a single one. So enter, close parentheses and enter. So yes, this is our rate of change now. Now let's format. What am I saying? The formula in this program do this refers to a range that has an additional number. Okay, let's format the number to 2 decimal places. Yeah, 3 decimal places. Let's leave it at 3. So what this simply means, right? Let me just use the color. Yeah, let me bold in the text so we can see. So what this simply means, Control T, yes, all right. So I just convert this into a table. What this simply means is this is our rate of change. That means between 1990 to 2025. So that means annually, Abuja temperature increases by, you see that there is no negative. So that means they are all increased. That means all these locations are temperature, they are increasing. And it means that annually, the temperature increases by, for Abuja, the temperature increases by 0.052 degrees Celsius per year. Let's sort it. Abuja has the highest rate of change, followed by Enugu. Yeah, and the city with the lowest temperature increase is Lagos. Let's see if we can change here. Custom setting. Let's go to custom setting. We want to sort by rate of change. Yes. I hope you see what I did there. Let me show you. I want to sort this from highest to lowest. So we'll go to the drop down by city. Under sort by color, you will see custom setting. Click on custom setting. You come here and change sort by. We want to sort by rate of change. And then the order is largest to smallest. We don't want largest to smallest. So okay. Why is Lagos disappearing now? Why am I having value error? Oh, wrong data type. If a value used in this formula is of the wrong data type. Let's rewrite the formula. I don't know what happened, why the change, but let's see if we can change to F2. It's supposed to be 39. Why 37? Why did it change to 30? Okay, you see where the error is coming from. I don't know why the formula changed, increased to 39 instead of the 37 that we used. But we have seen it now, so let's quickly. I don't know what happened, why the formula changed. Well, let's see. Then enter. Yeah, so we have sorted that one out. The error was because the formula kind of included this value error that we have here, the total distance that we have here. That was what happened. Let me just clear that part. That was what happened. And so now Abuja has the highest rate of change, followed by Enugu. Thus Lagos has the lowest rate of temperature change, lowest rate of temperature increase. So we're going to be using, let's change the name to warming rate, so that it's more self-explanatory. So let's insert our charts for this. I'm going to be using a column charts. Or what's this color? Why is it giving me orange color? Anyway, we'll be doing the editing later. So yeah, so you see we have, let me just remove the title section so that it's bold for you to see. So this is our chart for that purpose. Like I said, we'll come back to formatting and everything that we need to do much later when we are building the dashboard. The next analysis we'll be doing is to calculate temperature variability. Another thing I wanted to understand was how consistent or unpredictable temperature were over time. It is one thing to know the average temperature per city, which we've already done, but here, and we've also done the analysis for the rate of change. That's how temperature changes in each of these locations year after year, yearly, how temperature changes, the rate at which temperature changes yearly. But here I want to understand how stable or unstable temperatures are in each of the city. Like which of the city has the most stable temperature and which of the city has an unpredictable temperature. Like which city's temperature is most unpredictable. So I want to calculate like how temperature fluctuates in each of the city. How does it fluctuate? Which city has the most stable temperature and which city has the most unpredictable temperature. To do that, to get our temperature variability, I'll be using Excel's standard deviation function. We are still going to be using this our table, this and average temperature. We can a low standard deviation means the temperature is relatively stable from year to year, while a high standard deviation means temperature fluctuates more, indicating greater climate variability. Right. So in Excel, standard deviation function says stdev dot s sit here. This is the formula. So it estimates standard deviation based on a sample and ignores logical function, logical values, and text in the same sample. So this is what we are using, STS. So this is the argument it takes, number 1, number 2, which are optional. So we are going to be using, the first location is Abuja. So this is, we are just going to take in the series. The formula is not, so Abuja is C2 to, we are dealing with, the last here is C37. So let's go back. C2 to C37. Let's see if our Abuja is highlighted correctly. Yes, it is. So we enter it. The next is Enugu, so equals to stdef.s. Where does Enugu fall in? D, so D2 to D37. D2 to, I could have even freeze that column. D37. So that I don't move. Close our parentheses and enter. So this is our temperature variability. Let's clean it. Let's clean it to 2, 3. Let's leave it at 3 decimal places. Yeah, 2 decimal places. Let's leave it at 2. And then let's convert it into a table. Control T and OK. So this is it. This is our temperature variability. Is it sorted? No. Let's sort it. Okay, we want to do custom sorting. We are sorting by temperature variability. We want to sort by largest to smallest and OK. So yes, we have it. So Abuja has a most unstable temperature, followed by Kano, and Lagos has the most stable temperature. So Lagos and Port Harcourt has large water body. They are bordered by large water body. This may be the reason why their temperature is most stable, right? It's more stable than others. But this is subject to more further research, you know. But from this analysis, we can see that Lagos is the most stable, has the most stable temperature. Let's put our charts. We go to insert. We're going to be using column chart as well. This is it, our temperature variability. And it is already arranged orderly because our table is sorted. Something is wrong. Kano started with, formula shifted. It's E2 to E37. Alright, so the formula shifted. So I just realized there was an error. That's why I corrected it. So yeah, this is it. The next analysis I'll be doing is actually charts. I want to use a line chart to see the trend, to give me a prosy look of temperature trend in Nigeria using these 6 cities. So the value I'll be using for is year. I'll be using this year column, and I'll be using this overall average temperature. So what I will be doing is to copy out these 2 columns, because those are the 2 columns that I need. This year column and this average temperature column. I already copied the year column here. So I have the year column here. The next thing I'll be copying is this column. So I'll copy this. Copy, and I come here and paste the value. So I'm simply trying to, I want to clean this, reduce the decimal. So 2 decimal places like we've been doing. So let me just make it a table, Control C, and yes. So I'll be introducing a line chart. Let's go to insert. Let's go to a line chart. See how it came out. This is not a true representative of what we want to do. So click inside the charts. Then right click, and then go to select data. Select data. So this is it. The line chart, we wanted to show only overall average temperature. So uncheck this here. Pick on the year column and then OK. So OK and yes, we have it. Okay, so we come here. I want to introduce a trend line. So I have done so. I just click on the chart, this plot sign. You can remove your axis you can do any editing you want to do here. So I included a trend line here, and that's it. So this simply shows temperature trend in Nigeria. We can see how temperature has been moving up down, but we can see that it is consistently high. It is consistently going up over the 35 years study period. So we are going to be including the formula on this, the R square formula. So I click on the trend line, you see trend line options. This is just me trying to make the chart look more professional. I want to display the R square and display equation on charts. This is it. So R square of 0.4351 simply means yes, the temperature is increasing. It is increasing, but it is not a smooth growth. It is not smooth. But overall, we can see that there's an increase overall. Next thing we're going to be doing is map.
And that's it for the analysis part. We've taken the temperature data, walked through the analysis, and uncovered some really interesting patterns in temperature trends across Nigeria. But we are not done yet. In the next video, we are going to take everything that we've analyzed here and use it to build an interactive dashboard where we will bring the insights together visually and make the results much easier to explore. So if you don't want to miss that video, make sure to subscribe and turn on the notification bell so you'll be notified when the part 2 goes live. I will see you in the part 2.